All right, here we are on the last day of Phase 1, the note-taking part. That's Chapter 3, Lesson 1. This is the one about Earth's history. The last set of pages for Phase 1 taking the notes. Then we'll go back and do Phase 2, the processing, tomorrow. Okay, red pen or pencil for Continental Drift. You're probably going to also want a new piece of paper because we're almost out of space on this piece of paper. Continental, capital C-O-N-T-I-N-E-N-T-A-L. Continental, Continental Drift, capital D-R-I-F-T. Okay, the continents are South America, Africa, Antarctica, India, Australia. Well, actually, India I don't think is its own continent. It's considered a subcontinent. Europe, North America, Asia, those are the continents. As you've read, fossils of ferns can be found in places that now are cold all year long, places where no ferns grow. How are such finds possible? So they're wondering, how can a plant that needs a warm place to grow be in a place that's cold right now? Well, here we go. Wegeners Hypothesis. Now I know that's a W, but in German it sounds like a V. So Wegeners Hypothesis. Let's write that underneath here. Capital W-E-G-E-N-E-R apostrophe S. Wegeners Hypothesis. Capital H-Y-P-O-T-H-E-S-I-S. And a hypothesis is just an idea you can test. That's something I learned from Dinosaur Train. In 1915, German meteorologist Alfred Wegener proposed an explanation for findings such as this one. He hypothesized that Earth's continents slowly move about its surface. This idea was called Continental Drift. So he had an idea that the continents are actually moving. Continents, C-O-N-T-I-N-E-N-T-S, move, M-O-V-E, parentheses, slowly, S-L-O-W-L-Y. So slowly that we humans don't normally see it. We have to make special measurements to figure this out. Wegener's hypothesis was based on 4 pieces of evidence. First, the coastlines of South America and Western Africa appear to fit together. So, on a regular map, when you see South America and Africa, those shapes kind of fit. And it almost seems like pieces of a puzzle that should go together. Like pieces of a puzzle. Oh, hey, that's what they said. Second, fossils from the same plant and animal species were uncovered in both South America and Western Africa. So what they're saying is, like this animal, Synognathus, was found in South America, but also found in Africa. And if you fit those little puzzle pieces together, they were being found in the same strip of land. Lystrosaurus, same thing. You could find it in Africa, but also in India and Antarctica. Continents that are very far apart from each other today. Same thing for Mesosaurus or Mesosaurus. If you fit together the puzzles of South America and Africa, they are found in the same general area. Okay, where's the third piece of information? For example, the reptile shown on page 91 lived in fresh water. Page 91, that reptile. Okay, that's a freshwater reptile, meaning it lived in rivers and streams, not the salty ocean. It could not have swum across the large salty Atlantic Ocean and survived. Okay, that makes sense. So if this reptile lived in fresh, clean water, there's no way it could get from the southern tip of South America across thousands of miles of salty ocean today and end up at the tip of Africa. So millions of years ago, these two areas were probably much closer so that a freshwater animal would be able to live in both places. Third, deposits from glaciers were discovered in places that now have warm weather all year long. Deposits from glaciers. Oh, okay. So if some place is warm all year long right now, how could there be glaciers and ice? It must have been there long in the distant past, and it must have been colder. Fourth, mountain ranges across North America and Western Europe seemed to link up as if these land masses were once connected. Okay, so just like the coast of South America and Africa seem to fit like puzzle pieces, there are mountain ranges here in North America and all the way across the ocean in Western Europe that seem to fit together. Wegener hypothesized that all of this evidence could be explained if the continents had once been joined together. He called this landmass Pangaea, meaning all land. Although his evidence was strong, Wegener could not explain how continents could have moved. Yet 30 years after his death, scientists found evidence to support Wegener's ideas. They began to accept the idea of moving continents. So he had this idea all the way back in 1915. He understood a little bit. He couldn't explain the whole thing. And it wasn't until 30 years after his death that other scientists finally started figuring out how the continents were moving. Okay, let's go ahead and write down some of our evidence, right? South America and Africa coastlines. Well, let's actually draw a little picture, right? So there's South America. So let's do that kind of bulge. And then, okay, hold on. Okay, let's go ahead and do that little bulge of South America. And then it kind of goes down to like a tip. And then it kind of bulges out to the right. And that is South, capital S-O-U-T-H, America, capital A-M-E-R-I-C-A. And now, let's do Africa. So we're going to start right about there, come up, all the way out, and there's like a little point right there. And then it comes down, and it curves back up, and it sort of follows the coastline there, South America. And that is Africa, capital A-F-R-I-C-A. So that first piece of evidence was the coastlines. So number one, coastlines, C-O-A-S-T-L-I-N-E-S, squiggle, puzzle, P-U-Z-Z-L-E. So the coastlines of South America and Africa kind of fit together like puzzle pieces. Okay, evidence item number two was the fossils. Okay, number two, fossils. And then, how did they say it? Plant and animal species uncovered in both places. They're the same. So fossils, same, S-A-M-E, across, A-C-R-O-S-S, ocean, O-C-E-A-N. How could the fossils of plants and animals be the same across an entire ocean? Well, maybe they were closer together that far back in the past, or that far back in ancient history. Number three, deposits from glaciers. Okay, glacier, G-L-A-C-I-E-R, deposits, D-E-P-O-S-I-T-S, in, I-N, warm, W-A-R-M, areas, A-R-E-A-S. So glacier deposits in warm areas. Must have been colder and maybe in a different place in the past. Fourth, mountain ranges across North America and Western Europe. Okay, so number four, we're going to do capital N, capital A for North America, and, down three down, Europe, capital E-U-R-O-P-E, mountains, M-O-U-N-T-A-I-N-S. So North America and Europe mountains matching up. And that is what Pangaea looks like. So we need that word, Pangaea. Okay, let's go ahead and put that right up here. Capital P-A-N-G, and then they spell it a little different, A-E-A, A-E-A. Capital P-A-N-G, A-E-A, Pangaea. All right, let's see if we can answer this question. What was Wegener's hypothesis of continental drift? Well, Wegener's hypothesis was that the continents are moving very slowly. He had several pieces of evidence, including the coastlines of Africa and South America matching up almost like a puzzle piece. Also, scientists were finding fossils that were the same but on other sides of the ocean, like that freshwater reptile that could not swim across the ocean and survive today. Third, people were finding glacier deposits in warm areas, so it must have been much colder and much different in the ancient past. Finally, the North American and Europe mountains sometimes match up, kind of like the puzzle pieces of the coastline. Wegener's hypothesis was that there used to be one giant landmass long ago, and he called it Pangaea. All right, good. We were able to do that. All right, now, the visual summary. These three things are always the super most important things they think are really key to understanding what's going on, so we're going to make sure we have these in our notes. Okay, let's flip our page back over to the front. The rock record provides clues about changes to Earth's surface. Okay, where did we talk about Earth's surface and the rock record? Where's the rock record? Oh, that's the name of the section, the rock record. Okay, it gives us clues that there is change, and the change is happening to Earth's surface. Okay, we know that the youngest layers are on top and the oldest layers are on bottom, and that there are similar layers in different parts of the world, which is giving us clues about how things are changing. At first, scientists could not explain tilted rock layers and other observations. Okay, so things like fish bones or shells that should be in the ocean can be found in the mountains. Or people are finding land that can curve or fold, kind of like in the picture, how it's bowed down in the middle. So that rock record gives us clues that things are moving and changing. Okay. Fossils preserved in sedimentary rock are the remains of once living plants and animals. So here we go about fossils. They're found in sediment or sedimentary rock. The fossil record is information, or like a memory. It's evidence of plants and animals that used to live a long time ago, and we call all of those things organisms. We can learn what they looked like or how they lived. Fossils from the same species have been found on different continents. Okay, let's see if we had that somewhere. Fossils from the same species. We did talk about similar layers being in different parts of the world, but that was the rock record. I don't see that here in fossil record. Okay. Clues about the past. Fossils are a clue about their environment. Ah, here we go. Same organisms, different continents. So, fossils of the same species, or the same organisms, have been found on different continents, are being found on different continents. And that helped lead to Wegener's hypothesis. It was the part about fossils are the same across the ocean. So you could have the same organism. Let's actually draw a little picture here. Let's draw like a little band across South America and across Africa, and put number 2 here, and put number 2 here, so that it goes with number 2, fossils same across ocean. So the same fossils in South America were also being found in Africa, leading us to believe that those pieces or those land masses were closer to each other in ancient history. Evidence from the rock record, the fossil record, and ancient climatic zones led scientists to conclude that the continents have moved. So, looking at the rock record and realizing that some layers or some strata are the same, even though they're in different parts of the world, and you're finding fish and shells in the mountains, and then the fossil record is showing that there are the same fossils in different parts of the world, and then seeing that climate can change is leading people to believe that maybe things were closer together in Pangaea in ancient history long ago, and that they've been moving apart or drifting apart. Okay, everything here is in our notes, so we are good. Next time we will use our highlighter or a pen to highlight, underline, star, circle, add, delete, and all that kind of stuff for our phase 2 processing. Good job persevering with a growth mindset, and roar Wildcats.